Right. Shall I start? Okay. So we go by whatever last class we had discussed. Okay, we discussed the topic of refraction, saying that refraction is bending of light as it enters from one medium to another. So when you hear the word refraction, some of the hot words that should come in your mind is bending. Okay, bending of light. Sorry, bending of light. Then the other word that should come is that there should be an interface. Okay, and the interface will always be between two different mediums, m1 and m2. And when you talk about medium, the word medium you can associate with only when you have a difference in something called optical density. Is that fine? And optical density is not to be confused with mass density. While mass density will tell you how heavy or light an object is, optical density is just like the path of light, the medium through which light is passing. Is it like an ORR or is it like an old series out of a road? You are understanding, right? If the optical density is more, light finds it difficult to travel. I mean, these are, don't go and write the same words. These are for you to understand. Light finds it difficult to travel. So the outcome of it will be that light will slow down. So this is like a road which has got a lot of traffic. And if the optical density is low, then it's like a free highway. And light picks up speed. Okay, picks up speed. Now, since we have talked about, mentioned this word called picks up speed, so there is one more thing, that if you have a medium which is vacuum, or it is air, that is considered the best highway for light. Understood? Vacuum or air is the best highway. So here the speed is maximum. And this speed is equal to c. We denote it by c, and the value is 3 into 10 to the power 8 meters per second. That means you cannot have a medium other than vacuum and air where light travels much more faster. इससे ज़्यादा speed में कहीं नहीं जा सकता है. This is the fastest. Okay. So based on the optical density, okay, when we were talking about optical density, the optical density allows us to classify medium, that is medium versus medium. Now this is subjective. Okay, medium versus medium. If you have an optical density OD, if its OD is high as compared to the OD of this medium, then this medium could be called as a denser medium, and this medium will be called as a rarer medium. Now rarer and denser are subjective words. Just like if you say he's a good boy, then you start asking, as compared to whom? Who is your benchmark? Because your benchmark is the most notorious boy, and you found slight good qualities in him, and so you're calling him good boy. So if I actually show you a good boy, then the so-called good boy in your mind will become a bad boy. Do you understand? So it is very subjective. Based on medium to medium, it's just like currency. We are stronger as compared to the Pakistani rupee. However, if you compare the US dollar, that is more stronger to us. Clear? Okay. Now, this was all that we had discussed till last class. I hope you have gone through it. If still there is some bit of cloud or anything, you can ask. If not, so I'll try to now start our diagrams. We will have a lot of diagrams out here. Okay. So let's trying to illustrate you the concept of propagation of light. Okay. The concept of propagation of light as it enters from one medium to another. To make it simpler, what I have done, let me assume that this is something like a glass slab. You know what is a glass slab? A rectangular piece of glass. Those thick glasses which you have, just I think I have one. I should have one. I don't know. There was one. Is it? Yeah. So a glass slab is something like this. This is a glass slab. Yeah, this is a glass slab. Got it? So this is the glass slab that I have tried to draw. Okay. So 1 minute. It's simple. There is nothing, no great science in it. It's just a 24 mm glass sheet which has been cut into cuboidal manner. Glass is considered, yeah. Which one? Which one? Speak loud, better. Tell me. I'll explain once again.
What did you write below optical density?
Where? Below optical density. Here. This. I said if your optical density is high, the light finds it difficult to travel. Optical density high means you have a lot of, you're optically very dense. Optics means light and the medium is dense. So light cannot travel. And if your optical density is low, it is like a free highway. It's like the ORR. So light will travel very fast, right? Now we are taking glass slab and we have air on this side, okay? So our interface is typically say Mn is our interface out here. This Mn is the interface, right? Try and understand first. Glass, air is rarer. Now you will say, why? I have taken the best of the rarer. So anything compared with air, that thing will be denser. No question about it, okay? So my glass slab is, this is denser. Now let's see the magic, what is going to happen, okay? So we will have an incident ray. So this is my incident, sorry. So this is my incident ray, which is incident on the interface. Clear? This is incident on the interface. Slowly we'll get into laws and all. And as usual, if it is incident on the interface, I should have something which is known as the normal at the point of incidence. Till here, children, are we clear? This is the normal. Angle made by the incident ray and the normal is known as the angle of incidence. There is no issue. This is my incident ray. Many times we will draw this diagram. Don't worry. This is my normal. And let's say this is A and this is B. B is my point of incidence, which is this, right? Now, light is coming from a rarer medium. So light has come very fast. It's going to hit you. And after it has hit, so what does the law of reflection tell us? The law of reflection tells us that once there will be, one minute. Once there will be a ray of incident ray, there will also be a reflected ray. There is a reflected ray here also. In this chapter, this ray is not my concern because I am not studying reflection. I am studying refraction. But my study of refraction does not nullify the effect that there won't be any reflection. Reflection hota hai. In diagrams, you may not see this ray. This ray will always happen. Some ray will be reflected, some refracted, and some transmitted. Some will get inside the medium also. Okay, so let's see. Now, our study is all about refraction. Now, what happens? The light is coming from free surface. So this is like a child. Remember this story, you'll never make mistake. A child running in a playground will run very fast. And now the child will board the school bus as the last pickup child. The bus is already very full. Can the child run inside the bus with the same speed? No. Maybe the child may not get even a seat to sit in the bus. So it needs some support. The energy will be drenched out. When your energy drenches out, you need support. Support means a shoulder to lean on. Some support. That shoulder is your normal. So now you will just lean on the normal. And this is what in your book is written as, when a light enters from rarer to denser, it bends towards the normal. So let's get our story. Light is entering from rarer, mommy, running like anything, and then enters into the bus. All energy gone. Now when your energy is gone, you will need a shoulder to lean on. Who is the shoulder? Normal is the shoulder. And you lean on normal. And now the angle that you will make with the normal is known as your angle of refraction. Clear? This is known as my, 1 minute, Beto. This is known as my angle of 1 minute. 1 minute. This is known as my angle of incidence. And R will be known as my angle of refraction. 1 minute, Anurag. What I'm interested here for you to notice, I have shown that the ray, actually, if there was no change in medium, say suppose there was no change in medium at all. If there was no medium, no change in medium, no interface, my light should have traveled undeflected in this direction. Do you agree? The light should have traveled undeflected in this direction. Whereas, since it has entered an interface and it suddenly felt, till now I was in my home, now Papa Mama has put me in where? Hostel. Life has become very troublesome. Life is not no more that fast. Energy gone. I need some shoulder to lean on. The shoulder is the normal and you bend towards the normal. So this will make me right. This will make me right that when, and then I'm coming to your question. Light enters, don't say the word travel, enters from rarer to denser medium, rarer to denser medium, it bends towards the normal. Yes, Anurag, your question. Hey, Shreya, you have your refreshment and all and sit in my class, or everything is allowed. You can eat food. Only this camera should be on. That's all. Yeah, tell me.
Sir, so does the incident ray travel through the slab?
Yeah, it has traveled through the slab and it has gone inside the slab.
So what is the dotted line?
The dotted line is, suppose we would have not changed the medium. Imagine, Anurag, you are driving a car. You're driving, just imagine this scenario. You're driving a car on auto-lock steering on a straight highway. What are you driving on? You're driving on an asphalt surface, right? Say, suppose you don't have auto-lock feature and suddenly you just doze off. And on either side of your road, to make you safe, we have sand. And your tires just come on sand. Don't you think the tires encounter now a different medium from the asphalt road? And as you come on the sand, do you think you'll still travel straight? No, you'll just drift away somewhere. The same thing is happening to light. It was happily coming in an open, rarer medium and suddenly found an interface after which it has to gain entry inside a denser medium. The dotted line shows that if I did not have a difference in medium, my light would have traveled undeviated along the dotted line direction. Is this understood? No, the dotted line, listen first. The dotted line shows that this was the original direction of light. If refraction as a phenomenon never existed in this universe, light should have traveled. Light travels in a straight line. From grade 6 we are learning. But light did not travel in a straight line. Light bent. Why did it bend? Because it encountered a change in medium. Once it encountered a change, and we will see also why this bending happens and what are the factors. But let us first understand that if you enter from rarer to denser, you will always bend towards the normal. And many stories I have given you, a child boarding the bus cannot run inside the bus as freely as the child was running in the open environment before he or she boarded the bus. Agreed? Till this much clear? Can I change my slide? Yeah, please. Yeah.
What makes a object more optically dense?
It has to obstruct, it has nothing to do with mass density. That is what is called optical density. It is its inherent property by which it will allow either the propagation of light easily through it or it will slow down the light through it. That's it. That parameter is called density. What decides you are heavy? Density. Density decides you are heavy. Mass density. Mass per unit volume. In this much volume of, say, a table tennis ball, you can carry 1 kilo of iron. But if you want to carry 1 kilo cotton, can you take it in a table tennis ball size? No. That factor is known as density.
Sir?
And it is, 1 minute, it's easy for us to understand the mass density concept because it is packed and all. Here there are a lot of crystal stories also. In higher optics you'll learn that. But for us the parameter is optical density. If the optical density is high, it does not allow optics to travel through it. As simple. Yes, Anurag.
You know that medium bends towards the normal.
It's not medium. When light travels from rarer to denser medium, it bends towards the normal. Means, arre yaar, light bends towards the normal. Chalo. Okay? Story clear? Changing. Yes, we learned this in grade 2 also. But the point is that the life will be miserable now. That is more issue. Speak honesty. Practice honesty. Speak the truth. Be punctual. We are learning from kindergarten. Still not able to practice. अच्छा अली, अरे थोड़ा सा कैमरा एडजस्ट कर दीजिए बस, सीलिंग फैन थोड़ा कम, थोड़ा आपका या lovely face is not visible. Always he shows me Atomberg fan ad. Okay, can I change now, children? Okay, chalo. Now let's see the other drawings. So now I'll create 2-3 more diagrams. Okay. Now it doesn't mean that light always has to come from bottom or from top. Our concept should be understood. Okay. Okay. No more talking. So now again, I'm no more writing this as glass. I'm just writing denser, and this is rarer. What is this, sir? This is air. What is this? This is glass or glass slab, right? Now let's imagine that we have a light ray which is originating inside the glass slab. Okay. Now let's say this is the light ray which is originating inside the glass slab, right? Now my child is inside that packed bus in this heat of May or April in Hyderabad, and the child is about non-AC bus, not like you guys in AC bus, a non-AC bus, and now the child's bus stop has come. Mama is waiting outside. The child will struggle and get out, and once the child gets out, do you think the child will go slowly? No, mama, and run with full speed, right? The same thing, the light is now going to travel from a rarer, denser medium to a rarer medium. So it strikes here. My first job is to make the normal at the point of incidence. So this is my normal at the point of incidence. Have you understood this? Okay. Now, let's understand what are the phenomena that are going to happen. You are struggling from an optically dense environment, and you're now going in an optically rarer environment. Your speed will pick up. You will be more jubilant, more happy, more energy. Do you need any support? Now you will betray this normal, like, who are you? Do I even know you? And you will say, Mr. Normal, get away from my life. So we say it bends away. Now this is my angle of incidence and this is my angle of refraction. Agreed? And I will write now, when light enters a rarer medium from a denser medium, it bends away from normal. It bends away from normal. Few more things that we can write along with it, which we are right now not paying that much attention. Speed goes up. The speed also goes up. Do you agree? And if you see this diagram where 1-mark questions may make your life miserable, in such a case, R will be always greater than I. So this comes a question. If R is greater than I, is the light entering from rarer or leaving a denser or entering denser? So you should be able to answer. If you go to the previous diagram, out here you will always see I is greater than R. If the angle of incidence is more than the angle of refraction, that means light is entering from rarer to denser. And here we can write one more thing. Speed falls. False means, just apply some common sense. What was this environment? Air. Air has the maximum speed. So if you enter anything from air, your speed has to fall. Well, let's go to here. And you find that this is some other medium and this is air, the speed picks up. Are these two things clear now? Okay. Now a question also comes, sir, why does the speed of light actually fall or the speed of light actually increases? So let's understand that also. So let's say this is my denser medium. Okay, I'll change the color to yellow. Okay, this is my denser medium and this is my rarer medium. And my rarer medium is air. Denser medium as usual continues to be glass. Okay, a few questions to all of you. Apart from Phoenix Green, is in Rockwell, what are you doing in physics right now? Just quickly. Oh, you all are in electricity. In Glendale, what are you doing? Light what part? Lek. Mirror and mirror. Okay, what about Shloka?
When we just finished.
Lek. Lection.
Yeah, reflection concave.
Concave. So you are still in, and Samashti?
Convex. So then
Pehla means you are still in light reflection only. Reflection. How about you? Refraction also finished? Refraction खत्म हो गया बेटो आपका. Ritisha, what about you? Convex mirror. And how about time? Convex mirror. So you are still in lection. Rection has been studied only by Phoenix Green, and you have completed, you say. Yes. Oh, don't worry. I'll give you electric shock again when we study. Maja karo. And all you three guys, Ali and Anurag and Shreya, the entire video of current electricity is there. You just go to the playlist of previous year, you will get the entire video. That is as good as, just think that I have another batch whom I am teaching and you are not in that class. Don't think in your mind is everything. Don't think that that is previous year video. You assume that there is another batch I'm teaching and I'm teaching the electricity and I've punished you three guys. So you only see videos. Aap aise dekho. How about you, Aditi? You are still in lection?
in a convex
Lens. Okay, that means she has also gone inside. Okay, right, fine. Now let's see why what happens actually to the light rays. Okay, now pay attention here. Now look. This is a beam which is traveling. Okay, this is a beam. There are many rays. Say I'm taking 3 rays out here, right? There are 3 rays that I have taken. Now, what happens if I consider slight amount of thickness of this? There will be some amount of thickness out here, right? There will be some amount of thickness. The time taken, just see, in the same interval of time, let's say the first ray enters and it is, the first ray enters and it bends. The second ray actually travels a more distance and bends. Third ray takes more distance and bends. It's just like, have you seen athletics, 3 runners running? One has a more radius, one has a even further more radius. So don't you think in the same interval of time, the athlete who is on this track is actually running a bit more? That's why after the first lap, everyone is allowed to change and come into the first lap. The nearer you are to the circle, the less of the distance. Why do motorcyclists and car drivers, they all want to come on Formula 1, they want to come on as quick to the edge? Because nobody wants to travel more distance. If you travel more distance, your speed will, ultimately, if you have to jack up your speed. So what is speed? Speed is distance upon time. Into the same interval of time, this ray and this ray are traveling more distances. So overall, what happens? The speed of the beam falls. Because when I was explaining, I will tell you, you were talking to her and looking at her copy. Tell me yes or no. That is what you all do wrong. My eyes are like dragonfly and butterfly, okay? They also are seeing the screen, which these people might be thinking I'm not looking at them. Listen, consider a beam which has got 3 rays and it is entering an interface. The interface will also have some sort of thickness. Imagine them like 3 tracks of the track and field meet. A guy who is running on the 3rd track, don't you think he will always cover the maximum distance? Obviously, his radius is increasing. So in the same instant of time, while this ray travels from here to here, this ray will take more time. In the same instant of time, it will travel less distance. In the same instant of time, it will travel less distance in the same instant of time. So overall, what is happening? Speed is equal to distance upon time. You're traveling less distances. So your speed is falling. This is the attribute at the simpler level, at your level, to understand that when you enter from rarer to denser, you are actually bending. So for bending, more distance are being traveled by the far off rays. That's the reason attributed to why light rays lose their speed. So is rarer, denser, and this thing clear? Based on this, can we now say few things? What are the things we can say? We can say, Okay, you want the previous slide? Okay.
Sir,
Yes. Tell me.
but it's not related to.
Yeah, tell me anything.
Sir, if running race, the last person has to run the most like distance, then how is it fair?
That's why there is your problem, na. You guys only watch video game and Harry Potter. This fellow will be allowed to run from here. This fellow initial first lap will be placed here. This fellow will be placed here. Have you seen in race? Their positions are always calculated. They don't start. Only in 100-meter you start from the same line because it's a straight track. If it is a 400-meter, the track, and this is allotted on the basis of toss. After the first round, everyone can come to the inner circle. That's what people do. You will be placed in this manner. ठीक है? कोई बात नहीं. हर सवाल पूछ सकते हैं. चलो, shall we go ahead now? Where were we? Okay. So now we come to our favorite one more topic, which is laws of refraction. Now don't go and straight away write angle of incidence is equal to angle of refraction. Everything will go for a toss. In laws of refraction, we write the second law first because that's pretty easy to understand. The incident ray, the refracted ray, and normal at point of incidence all lie on the same plane, which is very similar to the law of reflection, second law of reflection that you studied. The incident ray, the reflected ray, and the normal all lie on the same plane. I will not write the second law immediately because all our pain problems will be with the second law. Before that, we'll come back to the slide. Let's see one more diagram. Okay, the same. Sorry, is this covered? Everyone has written this? Yeah. It's just like the reflected law of reflection. Refracted. That's, you got it. Instead of momos, it's dim sums. Dim sum. Instead of noodles, it is spaghetti. Instead of cake, it is cow dung cake. Makes it better? Okay, chale bhi. So let's get back to the glass slab diagram once again, okay? Now this is also sometimes a experiment which you do in your school classes. I don't know how much you all will do, but okay. So let's see the refraction once again. This is my rarer medium, and I have taken this as air. This is my denser medium, and I have taken this as glass. Okay, and this is again a rarer medium, which is air. So I should have an incident ray. So this is my incident ray coming from where, beta? Coming from rarer to denser. This is my normal at the point of incidence. So what will happen? Child has entered into the bus. So child will bend towards the normal. All right. So so this will be my I, and this will be my R. So far, okay? Now, after coming here, it has entered India from the western border. Now we'll leave India from the eastern border, okay? Now, concentrate on this part of the story. This is the incident ray. This is the refracted ray. The refracted ray now becomes incident ray for the next surface. Has the medium changed? No, the medium is still same. It was rarer to denser. Now it will be denser to rarer, but optical density of this medium was, say, OD1. This is still OD1. Do you agree? Well, both are rare. And this was, say, OD2. Refracted ray is in OD2. The next incident ray is also in OD2. Yes, now this is becoming the incident ray, right? So it has hit this surface. Initially, it had hit a surface, say, AB. Now it has hit the surface CD. But the story is different. If you look into this entry, it was R to D. Now the entry will be what? D to R. Very good. Intelligent children. Okay, I like that. And this is my normal. And like a selfish fellow, this fellow will say, who you are? I don't know you. And it will bend away. But one very interesting finding will happen here. Since the original medium and the exit medium are same, the bending away will be exactly parallel to this one. Are you understanding? See, this was OD1, OD2, OD1. If this could have been OD3 also. OD3 means from air to glass to inside a swimming pool, or my tears, water. OD1, OD2, OD3 it could have been. But we have taken OD1 to OD2, again OD1, right? So it will bend out. So here we will have some name changes. So let's understand them. I will call this as my incident ray. I will call this as my refracted ray. I can also call this as my incident ray. But mind you, when you're calling this as incident ray, this is incident ray for the interface DC. This is refracted ray for the interface AB. This is incident ray always for AB. Bacha, itna tak clear? This is clear. Now, after that, it has come back to the same environment. No further change of environment. Now I can call it refracted ray also, but I will call this as emergent ray. Emergent ray means finally emerged out. No further hindrances. Understood? Right? So this is R, parallel lines, alternate interior angle. So if this was my I1, my I2 will be equal to same as R1. Yes or no? Parallel lines, alternate interior angle, whatever was angle of refraction is now angle of incidence. And this will be my final angle of refraction. I can also call it as angle of emergence. Angle of emergence. And if this is E, this E will be equal to again I1. Why? Again parallel lines. See, parallel lines. So the angle will be same. Have you understood? But there is a catch here also. If this glass slab was not there, listen to me and then make the diagram. If this glass slab was not there, then you will say, "Pata hai mummy, main to bilkul aise jata." Kaise jata? I would have gone exactly. Arey. When you want it to go parallel, it will never go parallel. Okay, I would have gone like this. Agreed? I would have gone like this. My emergent ray has the same direction, but it has slightly shifted its course. So in physics, we say that there has been some let's say this is say D. This D is known as lateral shift. Earlier in grade 12, we used to have calculations on this. Now this is taken off. D is lateral shift. How much did the ray shift from its course? Direction will be same, but it will shift. So let's, this is called the glass slab phenomenon. Let's understand once again. I have a glass slab. So light enters from air, enters to the glass slab, again leaves the glass slab. It is entering from say OD1, OD2, again OD1. Incident angle, angle of incidence, angle of refraction. The refracted ray will again become incident ray for the next surface. And the angle of incidence for the next surface will be same as the angle of refraction. And put your stories together. Rarer to denser bends towards the normal. Denser to rarer bends away from the normal. But since these two ODs are same, this ray and this ray will be parallel to each other. And we say our emergent ray just shifted. It did not deviate. In a prism, you will see deviation. So when we study prism, we study angle of deviation. But in a glass slab, you don't deviate. You shift your course. So earlier you were in lane 120, now you're in lane 80, but you're still on the same track. This is called lateral shift. Please write down. And if you have not understood anything, you can eat my head. 1 minute. Anurag, I have a question here. What is the ray? That's a nice question which I did not take. Our boy has got a question and he says, what if the ray would have come 90 degree? Ray means 90 degree to the surface, means what is the angle of incidence? 0. if the angle of incidence is 0, right? So that means if a ray enters normally, it passes without any deviation.
So won't it bend away from the normal?
Children who are good, they will study in a party room also, they will study in their house also. Only children who have got tantrums, they will show all these things. I have examples.
Doesn't the speed change?
Normally, there is no change. You are not covering any extra distance. That's the same thing when you study it, that when you are hitting the pole, your angle of incidence and your angle of refraction is same. In a mirror, didn't you study that? Right? You were actually along with the principal axis, means if you make a tangent at the mirror, you are 90 degree with the mirror. What is your angle of incidence? 0 degree. With the 0 angle of incidence, the angle of refraction is 0. Mediums do not matter. This fellow is entering with a visa, man, from one country to the other. He doesn't go all this deviation. You are entering like a smuggler, so you will go in this manner. As simple as that. Yeah, Anurag, your question. Then I'll take yours. Yeah.
Can you explain lateral shift again?
Lateral shift. The lateral shift is the lateral shift. Lateral shift. Horizontal shift made by the emergent ray when it enters a glass slab from air and emerges out of the glass slab. Since the optical densities are same, therefore their law of refraction will be seen. There will be an incident ray, rarer to denser, denser to rarer. However, you will not follow this course. You will follow a parallel course. There will be a lateral shift. There is no change in your angle. But had this been prism, this angle will change. So therefore, in prism, we study angle of deviation. Here, there is no deviation. So all we study is lateral shift. So in fact, if you want to shift the ray, you can use a glass slab. Understood? Yes, Ananya, you had a question.
You pass a violet colored light through glass slab, it becomes slightly pinkish in color.
Pinkish in color because the edges behave like prism. Wherever there will be a triangular sort of edge form, why only glass slab? Have you not played that game after lunch in your class where you want to disturb some friend wearing a watch and putting the reflection on his face or putting that reflection on the floor? You'll see. If you have aquariums in your house and aquarium has got a curves on it, so once light enters from any side, say morning or evening, you'll always see some color formation happening because there is some prism formation happening.
Does the wavelength increase?
Wavelength changes. Speed of light, class 9 you all have studied. Speed is a product of wavelength into frequency. If the speed changes, either have to change. Frequency usually will never change unless you don't change the source. Source is what? Surya Dev. You don't have a different star which is enlightening you every day, right? So if the source does not change, the frequency does not change. Now, if you want to do up down out here, which parameter will undergo up down? This parameter will undergo up down. So wavelength changes. That's why we say visible light is from 400 to 700 angstrom or nanometers.
Visible light on the borderline.
Visible light, there is light. You know that electromagnetic spectrum. It is known as Gadi XUV in my range. Gadi, gamma, X-ray, UV, ultraviolet, in infrared, my microwave, our range. Between ultraviolet and infrared is what you see. Beyond that also there is light. In chemistry you will study bracket series, Paschen series, Balmer series. Then these are all which are very near to light, but you can't see. If you walk across a house which has got air conditioners outside and I blindfold you and the air conditioner and I put mufflers on your ears so that you can't make out the noise of the air conditioner, still you can say इनका AC चल रहा है. Why? You feel the heat. You are actually sensing infrared. You can't see that. But if something is made very hot and the room is pitch dark, you can see that red color. So light is between, there's a very narrow segment, 400 to 700. Beyond that, कारवार तो उसी में भी हो रहा है. So whether you are watching Star Plus or Jio Hotstar or your Airtel Signal or you are listening to BBC on radio, speed is always 3 into 10 to the power. You can actually do Go take a radio or just go and Google what is the wavelength of Vivid Bharati. They will tell you this is the wavelength of Vivid Bharati. What is the frequency of broadcast? This is the frequency of broadcast. Multiply both of them, you will get 2.99 into 10 to the power 8. Take out the frequency of BBC shortwave and take out the wavelength. That's why when we used to listen to radios, as I say, radios used to announce this is the BBC World Service transmitting on shortwave 1900 megahertz to this, and on medium wave this. They will announce this frequency is booked by every broadcasting station. This is the ABC Australia broadcasting on so much. Radios used to be very nice. So when I was at your grade, my first thing used to come up is multiply them and see whether they are traveling at the same time, right? So you will see the speed of the wave will be the same. However, the frequency and this will be the speed will differ because the wavelength and this differs. This experiment I used to do every time on 26 January. I used to switch on the radio in my school days. I used to switch on our television also, because the Prime Minister's speech will be aired live. So Rajiv Gandhi used to be the Prime Minister those days. So he will say Bharat ki Janta ko. It will come on television first because television is coming on VHF, very high frequency. Then on radio shortwave, Bharat ki Janta ko. Then after that it will come on radio medium wave. So that actually makes you that there are 3 different waves in which it's traveling. Correct? Is this understood? Time for us now to go to the second law. Yes. Yes. Yes, my child.
What do you write on top in blue?
This one. Oh, this was just to make her understand that speed is the product of wavelength and frequency. So if you want to vary speed, you have 2 parameters, but frequency does not change as long as source does not change. And source is sunlight. So if speed changes, must be wavelength changes. This we will study when we will study the human eye and the beautiful world. There we will see all these things. Shall we go back? Our next law is the most dangerous one, okay? The next law is known as Snell's law. And Snell has made your life like a snail. Snell's law. And please understand Snell's law very nicely, slowly. Ek baar mein nahi hoga. Snell's law says that the ratio, this is also laws of refraction, the second law. Ratio of sine of angle of incidence to sine of angle of refraction is always constant for a medium. Now this for a medium is a very dicey statement. Ratio of sine of angle of incidence to sine of. So he says that sine I upon sine R is a constant for a medium. But here I will add one word from my side. I will always say that you read it for a, instead of medium, you always say for an interface, and an interface has minimum how much? 2 medium, or you can say a medium pair. And in this medium pair, somebody will be rarer and somebody will be denser, has to be. If both are same, then refraction will never take place. इतना पहले लिख लो. और यहाँ से इनको ध्यान दो. अगले 20 मिनट में lot of kachras will happen on your head. Snell's law says that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant, and that ratio is named something, but for a medium ke jagah, you always understand as for 2 mediums for a medium pair, and in that medium pair somebody will be rarer and somebody will be denser. Okay, can I go ahead, children? Yo man. Okay, Anurag, sometimes put some positive charge on your finger and positive on your lips. They will repel. हमेशा खाते रहता है.
Yeah, I wasn't shouting here.
I am seeing you. Whenever my eyes falls on you, it comes out and it hovers around this place. Otherwise, it goes inside. There is one boy in my grade 12 class. he has to put something, otherwise he'll put the pen in mouth. और इसीलिए अक्सर पेट का बीमारी रहता है उसको. Okay, shall I go ahead? Where is this? Okay. Now, okay, I'm not using any scale. I'm just trying to draw it, and no, then the diagrams don't look good. I don't like that. Okay. All right. Children, now slowly forget about denser, rarer. This is medium 1. This is medium 2. Medium 2. Okay. Light has entered, and say, suppose we say medium 1 is rarer and medium 2 is denser. So this is what has happened. Agreed? And let me put my normal. So which means if this is I, then this is R. Perfecto? Okay. And now let's put Snell's law into practice. So Snell's law says, now don't write, understand, sine of I upon sine of R is equal to a constant, is equal to constant, and this constant is called refractive index. I won't say medium as of now. Obey what I'm saying. It's called refractive index. Agreed? Refractive index is represented by a Greek letter which is called eta. This is eta, ETA, or in higher books also by mu. You can stick to eta, though your book writes it like a n, but it is a lamba n. It is not n, it is eta. I have made it maybe a little bit longer. This is called eta, or it can be represented by the Greek letter which is mu. This is mu. Agreed? For our sense of understanding in this syllabus, we will stick to eta. Means this is refractive index. Ananya, you must be seeing it like this. That's why you call it n. But this is a little bit longer. So that you don't confuse, I am writing it like this. This is eta. Have all of you understood so far? This is known as eta. Fine. Now this refractive index can be of two types. One is called absolute refractive index. One is called relative refractive index. Have you studied this content properly? Do you know it very nicely? Can you take stylus and come here? Then that is half knowledge. 1 minute. In half knowledge, I always say your condition is like, have you seen a microwave oven? There is a sticker behind it. Do not attempt to open the back cover. Call only a qualified technician. Potential hazard of electric shock. सिर्फ मौत हो सकता है. और अभिमन्यु. History will remember you like that Chakra Yodha, but actually you were killed. So thoda thand. I'll come to that. And after that, if it is not answered, I'll come to it. Yes, tell me.
What would be called?
This is called ETA, ETA. Expected time of arrival, ETA. Or ABS means absolute refractive index. That's why you also, Shreya, you are also busy writing. This is getting recorded. First, listen. ABS means automatic brake locking system. No, absolute refractive index. This means relative refractive index. Now listen to me. Okay. Now say suppose I have reported a temperature on my body as 101 fever. How did you give me that figure of 101? 101 Fahrenheit. How did you give that figure? You must have put a thermometer on my mouth, right? 101 means there must have been some 0 Fahrenheit from where it has gone to 101. Generally, the body temperature will be around 36 and all, but from 0, 101. So 0 is taken as your benchmark. At that time, you say that my fever is an absolute fever, or my absolute fever rating is 101. But say that day Vakul is also having fever. He is at 99. Then my relative fever as compared to Vakul is only 2 Fahrenheit. Do you understand? 2 Fahrenheit. Is this concept understood? Absolute is when you measure me with some benchmark, which the world recognizes. 0 scale. Every world recognizes. But when I say relative, then it is not a perfect measurement. If I say, today I'm having a relative fear of 2 Fahrenheit, how idiotic I'm talking, then you will say, 2 Fahrenheit, your body is so hot. Have you taken medicine? 2 Fahrenheit. I said, yeah, as compared to Vakul, he's at 99, so I'm 2 Fahrenheit relative, 101. But this fellow is normal. He's at 95. At that time, I say, my fever today is how much? 6 Fahrenheit. So whenever you talk relative, your relative, you have to mention the two things. What is you and who was your benchmark? But when you talk about absolute, it is, you did not say the benchmark. It is universally accepted. One more example. The Indian rupee today trades at 91 rupees, the US dollar, and say some other rupee trades, say the Pakistani rupee is trading at 190 rupees, the US dollar. So for all international trade, the US dollar is taken as benchmark, and then all currencies compared to it, you can get to know they are strong or this. But if you go and say, Indian rupee, okay, as per Zimbabwean dollar, we are this much, we are that becomes very confusing. But we will need this also, this also. Now come back to the story. When you are talking about absolute refractive index, obviously this is sin I by sin R. The I has to come from the benchmark medium, which is air or vacuum. And this can be any goddamn medium, any goddamn medium. Understood? In such a case, this ratio, sin of I by sin of R, don't write, look what I'm writing, is always written as, now your book will write in one manner, I will write in one manner, then it will become easy for you to understand. It is eta, and eta is written as 2, 1 out here. Now absorb. If the clock goes 10 minutes more, don't worry. On top, we always mention the medium from where light enters. If the light would have entered from this side, then on top we will mention 2, right? On the bottom, we always mention where it entered. And here from where it enters, and here it is from where it entered. Have you understood? Right? Understood? So incidence, always the incidence part. Now in your book, this thing will be written as sin of I upon sin of R. They will write it as eta 2, 1. You are supposed to read it as refractive index of medium 2, WRT means with respect to medium 1. Now I find this confusing at the start of the chapter, so I say it like this. Look at me, likhna baad mein. I've added a word with respect to. In our Indian culture, whomever we give respect, हम उन्हें ऊपर बिठाते हैं. तो हम यहाँ with respect to what? 1. इसीलिए 1 is put on top. That is the best way to remember. If somebody writes eta, say AB, how do you read it? Refractive index of that's why this becomes confusing. Refractive index of A with respect to B. This can be also written as A with respect to B, and I say stick to this nomenclature. This will make your all calculations easy. A with respect, nothing wrong. Many books will write like this. A with respect to B. Jisko respect diya, whom you give respect, you make him sit at a higher level. And that higher level is always the medium from where light is entering. And the lower level is always the medium to where light entered. The top is always the medium where the incidence is happening. The bottom is always the medium where the refraction is happening. Is this nomenclature understood? Okay. Now I said that now we need to talk about something, and I cannot leave it, huh? So bear with me. We have absolute, we have relative. And I said when you are absolute, now see children, this can be kerosene, this can be water. Then you will write water with respect to kerosene. Okay, let's freeze this at glass. This is kerosene. Glass with respect to kerosene. Acrylic. Glass with respect to acrylic. Glass with respect to glycerin. Glass with respect to mustard oil. Glass with respect to castor oil. Arey bhai, what is the refractive index of glass? There can be many values depending upon what you are comparing with. But if you Google now, Google will tell you the refractive index of glass is 1.33. So they must have some American dollar as their benchmark. And who is the American dollar? Air. So if this is glass, right? And let's say this is some medium M1. This is some medium M1, right? I'm not changing the screen, right? And I'm bringing, okay, I am bringing 2 on, I'm just writing 2 out here. 2 is written here. So Snell's law tells me, again I'm writing Snell's law. Snell's law is sin I by sin R. I will write it as eta glass with respect to a medium M1. Right? If M1 is air, then I will write it eta glass with respect to air. Now I am reporting absolute refractive index. Every material has a refractive index in a table in Google. That is when they took the entering medium as air, because you are comparing everything with air. Then I will no more write this air, you just write eta G. So next time you see eta G, it is understood that on top A is there and it is absolute refractive index. And it will have only one value. And just for your knowledge, I may be wrong, this is around 1.33 say. And this does not have any unit because it is an angle over angle. It will not have any unit. Wait, the question will come. Is this much understood? No writing. I'm changing my slide. Give me that chance. So I say sine of I upon sine of R is equal to 2 over 1, right? Which in your book is written as 2, 1. Now there are some things. If 1 is air, then sine I by sine R is equal to eta 2. I'll just write eta 2. I won't write air on top. And this is absolute refractive index of medium 2. Understood? And if it is not air, it can be anything, glass, glycerin, jo bhi socho, then I call this is relative refractive index of medium 2 with respect to medium 1. And whomever we give respect, we make him sit on the top. Clear? So sometimes in book, they will give you a question. The refractive index of water is say 1.47. What did they say in book? Refractive index of water is 1.47. They are not saying me anything like the relative refractive index. Neither they are saying the absolute refractive index, but they have said the refractive index. They have said the Indian rupee today is trading at 91 rupees. What should you take the benchmark? US dollars. That means the question is said like this. The refractive index of H2O, I may be wrong on my values, don't worry on that, is 1.47. So in this question, you will straight away write, given eta water is 1.47, and in your mind, in your beautiful mind, you are understanding eta water with respect to air is 1.47, sorry, 1.47, and in your beautiful mind, you have already made a diagram where there is air on this side and there is water on this side. Light is coming from air and entering inside water. Now you just see incidence is on what? Air, with respect to air. Another question may be that, the refractive index of water with respect to, say, kerosene is X. At that time, you will write it as eta water with respect to kerosene. Means on top it is kerosene, interface bottom is water. Acha, if somebody tells you something like this, eta acrylic and kerosene, what do you mean? What do you mean by this? It means refractive index, relative refractive index of acrylic as compared to kerosene. Light is entering from kerosene and getting inside acrylic, not the other way around. No, sir, I want light to enter from acrylic and get inside kerosene. Then it will be like this. Light is coming from acrylic and getting inside. So I will call this as relative refractive index of kerosene with respect to acrylic. I stop my discussion here. And if somebody does not study this and come, you are to yourself on this video. You can have doubts. This is not so easy to absorb. You will, because this is just the start. This is just Ayodhya Kand. There are many other Kands in Ramayana now. Next two classes, next class will have many examples and problems. So if you don't study this and come, any questions at this level? Yeah, don't pack up. Wait. Have respect. Somebody has a question. The class is not yet over. Yeah. If it is not in, you know the angle, and for sine you get an angular value. There is a trigonometric table book available in our days, and in your days there is a scientific calculator available where you can input any value, sine 28.7, sine 31.7. But for your CBSE children, they will not give you all those. They'll give you what? 0 degree, 30 degree, 45 degree, 60 degree, and not 90. Because if it is 90, no, it's not normal. Normal happens at 0. I knew you would give that answer. 90 degree means it is coming along the surface. 90 is the angle of incidence, angle made with the normal. If it has to go like this, then the angle of incidence is 0 degree. What is the angle of incidence? Going to show this way. What is angle of incidence? Angle made with the normal. If this angle is 90 degree, then you are not even entering. तुम तो ऊपर से चले जा रहे हो. Physics is interesting. Yeah, any questions so far before I close? But please revise this section on the video and come. Otherwise, your life will be miserable in next class. And don't expect me to pull you up. Yes, one more question. Wait.
So if medium one is anything other than air or a vacuum, then it will be relative.
It will be always relative. If you are comparing my currency, anything other than US dollars, then it will be a relative comparison of my currency. You got it. And if it is air, that's why in the first day I said, air is your daddy. Remember that. So air is supreme. Nothing can allow light to travel more faster than air. Got it? And that's why you find, anyways, that I'll tell you in next class, not now. Otherwise, you'll get confused. Okay, can we close? Anurag, you can just bite your nails or fingers a little bit. This has been quite long. You have not done. Oh, have your nails bitten, you know.